Alright, so this is lesson 3.3, solving for vector components. Now I'm going to skip the do now. I'm going to explain it really quickly, right? So the do now question was, well, what happens to your horizontal velocity of the crate as the airplane releases the crate? So you can say that, well, you can see from this image, if your crate starts with an initial velocity of 150 meters per second, well then over time, as the crate is released from the plane, well then you're going to continue traveling at a horizontal velocity of 150 meters per second. Why? Again, there's no acceleration due to gravity in the horizontal direction. But I want to focus on something. Right? I want to focus on something here. I want to focus on this image in particular. And you see here that there's an x axis and a y-axis. So you can see a horizontal velocity and you see a vertical velocity. Well, what is this here, right? What is this v here? It doesn't really particularly have a component. And well, if you take a look down here, you see that your velocity angle, I mean your line changes as well. Well, what could that be? Well, that v there is your total velocity at a singular point. Right? That's the velocity of the object at that point in time. Because at this point in time up here, your velocity is going this way, right? The velocity of the crate is going this way. And down here, the velocity of the crate is in this direction over here. Well, how do we get that velocity vector? How do we get this line? Well, you should kind of realize that, well, that velocity line is maybe a combination of your x and a combination of your y. And somehow adding these two vectors together will get you this line right here, right? This total velocity, this resultant velocity. And so in this class, we're gonna talk about how we solve for vertical components, or rather vector components. I'm sorry. So let's say we have a triangle, right? Let's say AX is, I don't know, let's say AX is 4 and AY is 3. Well, if AX is 4 and AY is 3, well, how do we solve for A? What number is A going to be? If you recall in your math class, well, if you recall in your math class, you can solve for sides of a triangle. One way to solve for sides of the triangle is the Pythagorean theorem. Right? If you have 2 out of 3 sides, you can solve for the third side using this formula. Now, on your reference table, the Pythagorean theorem is given to you. Right here. Pythagorean theorem on the bottom. That's Pythagorean theorem. So let's do a practice question. So the horizontal component, projectile's launch angle above the ground. The horizontal component of the projectile's velocity, Vx, is initially 40 meters per second. So Vx is 40 meters per second. Also, I forgot to explain that A can be anything. A is a vector. A is a vector. A can be displacement. A can be a velocity. A can be acceleration. A is any vector possible, right? It doesn't have to be just velocity. A is any vector. A is any vector. So when I say Vx is 40 meters per second, well, that's Ax, right? Because that's A can be velocity. And you're also saying your vertical velocity is initially 30 meters per second. So Vy is 30 meters per second. And the question says, well, what is the velocity object projectile was launched with? So they want to know Vi here, right? They want to know what your total velocity is. So we use the Pythagorean theorem, right? So you're going to follow this. We're going to do Vi squared is equal to Vx squared plus Vy squared. So Vy squared, Vi squared is 40 squared plus 30 squared 900 2500, and then you square root this and then you get 50. So now we solve for our side of this triangle, right? So we launched our projectile at 50 meters per second. That's the answer. So now let's say we want to solve for a side of a triangle, right? Let's say instead of solving for a, now we solve for ay or ax. And these are the two formulas you're going to use. On your reference table, it's right here. Your reference table just has the formulas readily available. Right? You don't need to remember them. We're not learning actual trig, right? I'm just teaching you these shortcuts for trig. And this is the shortcut, right? AY is this and AX is this. All right, so let's do this practice problem. Initial velocity of 60 meters per second, 37 degrees above the horizontal. So you launch this object with an initial velocity of 60 meters per second at 37 degrees above the horizontal. And they're saying that, well, your horizontal component of the ball's initial velocity is what? Right, what is Vx here? So since you have Ax and you have A and you have your angle, you're going to use this formula right here. Right? So Ax, so Ax is Vx is equal to A is Vi, and cosine theta. So Vx is Vx, Vi is 60, cosine 37. So on your calculator, this is what you're going to do. Okay, on your calculator, this is what you're going to do. Let me 60 cosine 37. You can usually just type it into Google Calculator, but when you type it into Google Calculator, you have to make sure you're using degrees and not radians, okay? Very important that you are using degrees here. You are using degrees. You're going to do 60 cosine 37, and we get 47.9. Alright, so that's what you do on a calculator. Make sure, again, your calculator is on degrees and not radians. So yeah, plug that in. 60 cosine 37 is 47.9. Meters per second. So next problem, it says again, initial velocity of 15 meters per second at an angle of 35 degrees. Your initial velocity is 15 meters per second, angle of 35 degrees, right? That's your angle. About the horizontal. What is the vertical component of the golf ball's initial velocity? Vx is equal to, no wait, you're looking for a vertical, right? Vy is equal to question mark. So which formula are you going to use? Well, you're going to use this one, right? Because everything you need. So Vy is equal to Vi sine theta. So Vy is equal to Vi 15 sine 35 degrees. And you're going to plug this into your calculator. 15 sine 35. Again, you're going to make sure it's on cos degrees. So 15 sine 35, you get 8.6. 8.6 meters per second. And so that's your vertical velocity. For C, baseball is thrown at an angle of 40 degrees. So that's your angle. Above the horizontal component on the baseball's initial velocity, right? So it says horizontal component is that, and they're asking, well, what is your ball's initial velocity? What is this? Well, we have Vx, so we're gonna use this, right? So Vx is equal to Vi cosine theta. Vx is 12. Vi is that cosine 40 degrees. Well, you want to solve for Vi, so we're going to get rid of cosine 40. So we're going to do this. So we're going to divide cosine 40 on both sides. Divide cosine 40 on both sides. So 12 divided by cosine 40. 12 divided by cosine 40 is equal to 15.7 meters per second. Okay. So let's now actually try and solve for our angle. Let's say a question wants you to solve for your angle. They give you everything else, but, well, let's solve for angle. What do you need to do? So let's do this practice problem first. So a projectile is fired with an initial velocity of 120 meters per second and an angle theta above horizontal. So Vi is 120. If the projectile's initial horizontal speed is 55 meters per second, then your angle measures what? All right. So we have Vx, so we have Ax, so we use this. So Vx is equal to A, which is Vi cosine theta. And again, we want to know what theta is, right? We want to know what theta is. So Vx is 55, Vi is 120, cosine theta divided by 120. Okay. But to get rid of, so we have 55 divided by 120 here. Because cosine theta is here, to get rid of a cosine theta, what you have to do, I'm not going to teach you why. I'm not going to tell you why we're doing this. This is something you're going to do. To cancel out a cosine, you have to multiply by cosine negative 1. And so then you're going to multiply cosine negative 1 on the other side as well. So cosine negative 1 this. And so on your calculator, on your Google calculator, you press inverse and press cosine negative 1. On your calculator on your phone, I'm not sure how you do it. You just have to flip it to like portrait mode or something. I don't know, or landscape mode. And there's like this cosine negative 1. But here on Google, you're gonna do inverse cosine negative 1, and then you're gonna do 55 because that's what it says divided by 120. And this, then you get 62.7 degrees. Right, so you're gonna get theta is equal to 62.7 degrees. All right. If I have an initial velocity of 80 meters per second and the angle theta above the horizontal, if the projectile's initial vertical speed is 45 meters per second, then the angle measures what? So your initial velocity is 80 meters per second. If your projectile's initial vertical speed is 45 meters per second, then the angle measures what? Alright, so you're solving for Vy. Vy is equal to Vi sine theta. Vy is 45. Vi is 80. Sine theta. So you're going to divide by 80 on both sides. So you get 45 divided by 80 equal to sine theta. To get rid of the sign, you got to multiply both sides by -1. Multiply both sides by -1. Then you get theta is equal to this. So sine -1, 45 divided by 80. Inverse sine -1, 45 divided by 80. You get 34.2. And so your angle is 34.2. 34.2 degrees. Okay? Good. Easy. And that's how you solve this question. All right, perfect.